And okay, the next topic and is, as you can see, is a simple formulation of Gödels Incompleteness Theorem, and maybe in the next few days or few weeks or few months, I don't know if I have time, and we will share the whole proof of the Gödels Incompleteness Theorem, because I think this theorem is worth sharing. It's very interesting, and today I'm going to just say some just introduce it and use the simple expression, maybe the simplest expression to tell you what the Gödels Incompleteness Theorem is talking about, and why it's so important, and why it's so amazing. Today is not just think that I just wanted to talk something interesting and just an introduction, and it's easy. And the Gödels Incompleteness Theorem, and it shows that the mathematics and the logics, these two, in my opinion, is the most purest subjects in the world. But this theorem told us they are not perfect, they are not pure. It has something which we say that it's weird and it's not good enough. It's not good, and this theorem is talk about the pure logic and the mathematical logic, and it's in my opinion it's the simplest expression of this theorem is that. And when we consider a system, and what do we say system is in the pure logic, or we can say the logic system, or we can say it's a language system. What's the meaning of the language systems? That means that every word, every phrases, every sentence we used in this kind of sentence, in this kind of systems, that we need to define it beforehand. We need to define what we're gonna use it. If we do not define it, we cannot use it. Instead of our daily life talking, that we would talk something that we usually usually hear from others' mouths, then we will use it because we are familiar with it. But in this kind of systems, and in logic systems, in language systems, then we need to define what we're gonna use. And this systems and the Gödels Incompleteness Theorem is gonna talk about this theorem. Talk about this kind of systems. It is a proposition about these systems, and the most common systems in logic maybe is the proposition systems, or one order logic systems, something like that. And when we talk in Gödels Incompleteness Theorem, we are talking about the systems, and these systems only need to sacrifice one's limits and sacrifice one's condition, that is, it contains what? Contains natural number. What I mean contains natural number, because a system can't do its own words then without the natural numbers. If we don't define it, as I said before, want to use something in the language system, in the logic systems, we need to define the things we need to use. And although the natural number like 1, 2, 3, 4, 5, that's something like that, it's normal. It's the most normal things we may ever use. But in some systems we may not use it because we don't define it. And the systems that in this theorem that you need to contain the natural numbers. Okay, and the system, and I want to say that this expression is the simplified expression, is not just accurate expression of this theorem. So I just want to introduce it, and in the following videos I will share it, and maybe I will share the whole the good and the no mistake, the correct, the definitely correct proof about this theorem. And back to our introduction, and this system contains a natural number. That's all the condition, and there is the amazing that outcomes from this theorem. That is this system contains lots of words and expressions, and always a sentence and all the proposition. This sentence contains what? Contains a proposition. Or we say expression, or sentences, or just a kind of sentence that want to tell us something. We say expression or sentence, which always say not contains, exists. Okay, exists. This is a proposition, an expression, sentence, which is correct, or we say its value is true. That's the we usually use that to judge something is judge some sentence is true or false, that kind of things. And this we must or it must contain something that it is correct or it is true, and at the same time the same preposition, and it is unprovable. Always say it can't be proved. What's that mean, can't be proved? That is, we prove that this system contains a sentence that can't be proved. Can you imagine? I think it is very interesting that because we can prove by theoretically, and that something or some claim, some sentence, some proposition is the thing that can't be proved, but it is right. But we can't prove it. We can't prove it in this sentence. That's amazing, right? That's the most amazing things, and this is even can be proved that something is that something can't be proved. Okay, that's all the simplified expression about the theorem, and maybe in the future, and I will introduce the whole proof about it. Okay, today's over. Goodbye.